5.4. Use medians and altitudes. This is on page 321 in your book, medians and altitudes. So our essential question is, how do I use these medians and altitudes of triangles? And of course our first question is, what is a median? What are you talking about with regard to this median? Hey, remember mid-segment. Go back to your 5.1 notes, mid-segment. We had the idea of going midpoint to midpoint. That's a mid-segment. But in contrast, this is a median. And a median goes from the vertex to the midpoint. So it's not midpoint to midpoint. It's a vertex to a midpoint. So this red line here is a median coming from this vertex and going across to the midpoint of the opposite side. And what's unique about these medians is, well, just like the other mid-segments and what else do we do? Angle bisectors and perpendicular bisectors. Medians also have a point of concurrency. A point of concurrency where all three of those medians meet at one place. But what's really unique about that point of concurrency, which we call the centroid, is that the point of concurrency is going to be 2/3 of the way from the vertex to the midpoint. So it will always be that this segment from the vertex to the centroid is 2/3 of the distance of the whole median. Or you could say it the other way, that the distance from the midpoint to the centroid is 1/3 of the entire length of the median. And what's especially unique about medians and this point of concurrency of the medians, which we call the centroid, what's especially unique is that the centroid is the center of gravity of this triangle. So in other words, if the material, look in your book here on page 321, if the material of this triangle was consistent, had a consistent density all throughout it, then that centroid, the point of concurrency of your medians, is your center of gravity. In other words, you could stabilize, you can balance that triangle upon that one point. Let's look now in your book still on page 321 at example 1. And they're telling us that in this triangle, Q is the centroid. So when you see the word centroid, think of center of gravity, think of median, the point of concurrency of the medians. And remember, medians, again, the distance from the vertex to the centroid is 2/3 of the distance of the median. And they're telling us that SQ, so this section here, SQ equals 8, and they want us to find QW. They want us to find the remaining amount of the median, and then also the entire length of the median. So like we said, going from the vertex to the centroid is 2/3 of the whole. So that's what we have here in this little equation. SQ equals 2/3 of the whole. And we know what SQ is. SQ is 8. So now we have 8 equals 2/3 times SW. And how would you solve for SW? How would you get rid of this fraction? Well, you multiply by the reciprocal. You multiply by 3/2, and then that would cancel out. And so you'd have 3/2 times, on the right side it would cancel out. On the left hand side you have 3/2 times 8, which reduces down to 12. So the entire length is 12, and then if you take away 8 from that 12, then you're left with 4. And that matches, doesn't it? Because remember we said that this from the vertex to the centroid is 2/3. So there's 2 4s, 2 lengths of 4, in this section, and then this last section has 4. So you can think of it as 3 lengths of 4. This first one has 2 of them, and then just 1/3 in the last one. Example number 2, and there'll be one like this on the quiz, and also on the tests coming up. So this is on page 232, next page. So the vertices of this triangle here, all they do is give you the vertices. And so what they've also done here for us is to plot it as a solution. But for many of the questions that you will have, you will only have the vertices, and you'll have to plot them yourself. And now they're asking, what is the ordered pair for the centroid? For the centroid. So what is the centroid again? Well, you can think of center of gravity. That's good, but how is the centroid created? It's created by medians, the point of concurrency of the medians. And what are medians? What do medians do again? Well, that's right. They go from the vertex to the midpoint. Well, I already have the vertex here, but how do I figure out where the median goes from that vertex? Well, it goes across to the midpoint. So what I can do is figure out the midpoint for this side here. And remember, for midpoint, you're looking at the average of the coordinates. So, for example, and you'll remember it's like x1 plus x2 over 2. That's your x coordinate. And y1 plus y2 over 2. That's your y coordinate. And so it's as if you're taking the average of the x coordinates. So let's look at just the x coordinates here. We have 2 and 6, and let's add, what's the average of 2 and 6? Well, we add them together. 2 plus 6 equals 8, and then divide that by 2, and that gives us 4. So the x coordinate of the midpoint is going to be 4, and that's really all that I need, because once I have the x coordinate, that tells me I can determine where that intercepts with this side, and so therefore the midpoint for this side is going to be 4, 3. And so this is going to be your median, and thankfully it's vertical, goes straight up and down, very nice. And so how long is that median? Remember that we want to find the coordinates of the centroid, and the centroid is 2/3 of the length from the vertex. The length from the vertex to the centroid, let me say it that way, the length from the centroid, vertex to the centroid, is 2/3 of the entire length of the median. Well, the entire length, we can just count the blocks here, 1, 2, 3, 4, 5, 6, or we could do the difference in the y coordinates. So 9 minus 3 gives us 6. So if the entire length is 6, then what we can do here is take 2/3 of 6, which you see is 4. And so the length from the vertex down to the centroid is 4 units. So we just count the blocks going down 4 units, or else we could take this coordinate and then subtract 4 from 9 and get 5. And that'll give us the coordinates of the centroid. So we did this with regard to this, the median that goes to the midpoint of this side. We could do it for the median that goes to the midpoint of this other side, or even this other one. But the one that is either vertical or horizontal, that's the key. The one that's either vertical or horizontal is the easiest one to be able to figure out what 2/3 of that distance is. So look for the median that's either vertical or horizontal when you're doing these types of problems. This would be a good time now to pause the video and do the guided practice 1, 2, and 3, which you'll see here in your book. Let's move on to altitudes now. So we've talked about medians. Remember, that goes from vertex to midpoint. Now let's look at altitude. Let's look at the altitude. This is a different internal segment. Altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to a line that contains the opposite side. So what that means is, here we have a triangle. This is an acute triangle, and this here in the red is your altitude. And think of it as a little plane. Look at my great drawing here. Here's a little plane flying along. And what is the altitude of that plane? Well, of course, you wouldn't measure the distance, diagonal distance. You, of course, are going to measure the perpendicular distance from the plane straight down to the ground. So here's your perpendicular distance. So this is your altitude, or that's also equal to the height of a triangle if you were to call this side of the triangle the base. But what if you have an obtuse triangle? Well, same idea. Here's a little plane flying along like this, and the height or altitude, he's looking at his altimeter on the plane, and it's again the perpendicular distance. But wait a second, where's the other side? Well, what you do is you extend this other side beyond. It's the line containing this other side, and so the perpendicular distance comes down to the line containing the opposite side. And example number, let's, yeah, here we go. Sorry, it's still in your notes here. The altitudes, just like the mid-segment and also the perpendicular bisector and also the angle bisector and the medians, the altitudes of triangles also are concurrent. They also cross at one particular point. And for altitude, that point is called the orthocenter. The orthocenter. Best way that I know of, that I was told by, in fact, Mrs. Williams, if you go to an orthodontist, what does an orthodontist do? They straighten your teeth. And so you can think of, since this is the straight distance down, the perpendicular distance down to the other side, which is the altitude, it's altitudes that give you the orthocenter. So when you see the word orthocenter, think of straight, and that's your altitude. It gives you the straight distance down from your plane down to the ground, and that is the orthocenter. And I kind of made a mistake here with the notes, and I included some other stuff, which was just a repeat, really, of these first two paragraphs. So go ahead and scratch out these three paragraphs, because they say the same thing, essentially, as these first two do. And it's important to know that these orthocenters, in an acute triangle, the orthocenter is inside of the triangle. In a right triangle, the orthocenter is on the triangle. The orthocenter is on the triangle. And in an obtuse triangle, the orthocenter is outside of the triangle. Here's your orthocenter way out here, outside of your triangle, when you have an obtuse triangle. So now would be a good time, if you would like, to pause the video and go through example, or the guided practice number 4. For the sake of time, I'm going to go ahead and skip over example number 4.